Hey, Mr. Harrodum here. We're going to go over how to go from grams of one element to grams of a compound back and forth here. Now, there are two ways to do this here. Okay, we're going to do first classic Harrodum. Okay. And how are we going to do classic Harrodum here? So we have 49.4 grams of magnesium fluoride, right? And we're looking for the grams of pure magnesium. We know that these are not the same thing here. So classic Harrodum actually does this with the mole ratio. So you know what this involves, right? So you're doing the decomposition of magnesium fluoride, right? Magnesium fluoride decomposes into magnesium and fluorine gas, correct? We are starting off with 49.4 grams of magnesium fluoride. We are looking for the grams of magnesium. So we're going to go down the moles, over the moles, and up to grams, correct? Which would involve, of course, 49.4 grams of magnesium fluoride. We're going to do 3 steps. And then we're going to get an answer, correct? Okay, starting off, grams on the top, grams on the bottom, whatever you can convert to, moles. Okay, trust me on the molar mass here. It's 62.3 grams of magnesium fluoride per 1 mole of magnesium fluoride. Then you do your mole to mole ratio here. You have 1 mole of magnesium fluoride, right? And then you're going to switch it over to magnesium. So this is going to be 1 mole of magnesium. I should zoom in. I don't even know if I can. Maybe later. And then you have your 1 mole of magnesium down here. And your molar mass of magnesium is 24.31 grams of magnesium. And you solve that. And I get 3 sig figs, 19.3 grams of magnesium. Okay, that is the classic Harrodum method, okay, which works on everything. That's why I love mole ratios and maps. That is the classic way to do this. Okay, do you want me to show you the unclassic way to do this? Okay, here's the unclassic. I don't even know if that's a word, but there's an unclassic Harrodum method here. This only works for going from a grams of compound to grams of an element. Okay, you can do the percent composition. So what I do in this method here, magnesium and fluorine, find the molar mass. This is 1 times 24.31. So this is 24.31 grams. Fluorine is 2 times 19.00. That should be 38.00. You add the two together, you get that 62.31, or let's use 30 here. 62.3 grams per mole. Okay. So then I find out the percent composition of magnesium. So this is 24.30 grams of magnesium in 62.3 grams of magnesium fluoride. Now, usually you would see me multiply by 100 here. I'm not going to multiply by 100 here because I'm just going to use this as a conversion factor because I know that there's 24.3 grams and 62.3 grams of magnesium fluoride. I am just going to multiply that by my original number of magnesium fluoride, which is 49.4 grams of magnesium fluoride. So go swish that way. Scribble. Okay. Wonderful. And I get the same answer of 19.3 grams of magnesium fluoride. Okay. Most of the time, you're going to see Harritum do the classic Harritum tricks. Going on to the next problem. Page 7. Okay. Here we go. How many grams of oxygen are present in 156.8 grams of calcium phosphate? Okay, here. So first we're going to write out what calcium phosphate is. Okay. Here we go. Plus 2 minus 3. Calcium phosphate is Ca3PO4 2. Okay, so you're going to see me write an atypical reaction for this one. Going to separate this into 3 calciums, 2 phosphoruses, and 8 oxygens. Okay. This doesn't say oxygen gas, so I'm going to assume that oxygens here is referring to just oxygen here. I know it gets a little confusing at times, but yeah, that's what we're going to do here. So we're going to start off with 156.8 grams of calcium phosphate. We are going to find the grams of oxygen here. So you're going to go down the moles, over the moles, and up to grams. Okay. So we're going to do a molar mass here. Okay. We're going to do a mole ratio here. And we're going to do a molar mass here. Okay. Starting off with 156.8 grams of calcium phosphate. Gotta find the molar mass of calcium phosphate. 3 calciums, 2 phosphoruses, 8 oxygens. Calcium is 40.08, 120.24, 30.97, 61.94. 8 times 16.00, 128. 120.24 plus 61.94 plus 128. 310.18 G/moles. Down with the gangsters. So we're going to do first step, go to moles. 310.18 grams per 1 mole of calcium phosphate. Next step, we're going to do the mole to mole ratio. 1 mole of calcium phosphate to, I'm going to use 8 moles of O, since I broke them all apart into their individual atoms here. Okay. And then, just to confuse you some more here, 1 mole here of oxygen. This is just O, so I'm going to use 16.00 grams of oxygen to figure out the molar mass. You Could have also done 4 times 32, but you have to label it. Yeah. It gets confusing with the labeling, and yeah. And we got 4 sig figs here, so we're going to do 64.71 grams of O in calcium phosphate. Okay, one more we're going to do here. This is one I definitely do a more issue on here because we're doing potassium carbonate here. This one makes more sense with potassium carbonate. We're going to break this apart into potassium and carbon. Why am I writing 3 carbons? How about 1 oxygen, Mr. Harridan? No, Mr. Harridan. No, Mr. Harridan. Come on. 3 oxygens and 1 carbon, right? Even though I wrote them out of order or whatever. Okay. So we're looking for the grams of potassium carbonate here. We are starting off with the grams of potassium. So this one, we go down the moles, over the moles, and up to grams, correct? Correct, Mr. Harridan. Of course we do. So we do 35 grams potassium. We're going to do 3 steps on this one. Okay, step 1 is to go the moles here, so we're going to use the molar mass, 39.10 grams per 1 mole of potassium. Remember, molar masses are per 1 mole. Then we're going to do our wham, 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 wham. Then we're going to have 2 moles of potassium on the bottom here. Going to switch colors, because we're switching substances. I didn't switch colors on that other one, Mr. Harridan. Oh my goodness, aren't you paying attention? You're going to get all your students confused. 1 mole of K2CO3. Then we're going to do 1 mole K2CO3. I'm going to use the molar mass, 138.21 grams of K2CO3 per 1 mole. Hopefully you know how I found that. And then since this number has 3 sig figs, we're going to round to 3 sig figs, so this is 61.9 grams of K2CO3. So, in general, just use the molar-molar ratio. It just makes it a whole lot easier. Okay. Guys are champions. The legend is out.